equivalent expressions are expressions that have the same value. In example number 1 here, we want to know which of these are equivalent to y over 5. Or we could read this as y divided by 5. This horizontal fraction bar can be read as divided by. And so option A is out, right, because we're not subtracting. B says 5 divided by y. Well, that's not what we're doing. We're doing the opposite. We're doing y divided by 5. So B is out. We'll come back to C here in a minute. D is y divided by 5. That's what this is saying. And so we would circle D. D is equivalent to this. E, we're adding y plus y plus y plus y plus y. So we're not adding. This is not the same thing as adding. So E is out also. So let's go back to letter C. Now letter C, I'll tell you, is equivalent. 1/5 y is the same as y divided by 5. The reason is because dividing by 5, which we're doing here, dividing by 5 is the same thing as multiplying by 1/5. Or we could say this, y over 5, there's actually a 1 in front of the y. Just like before, we've talked about how when you don't see the coefficient in front of the variable, the coefficient's 1. Well, same thing here. We could say this is 1y over 5. And if you do that, you can see how there is a 1/5 right here. I circle 1/5. 1/5 times y. 1/5 times y, which would be 1/5 y. Example number 2. Which of these are equivalent to 2x plus 6? Well, in example, or letter A right here, we have 6 plus 2x. This is equivalent, right? This would be the, yes, this is equivalent. The commutative, I'll use C for commutative, the commutative property of addition, right? Which tells us that it doesn't matter what order that we add things, we'll get the same sum. Letter B, let's simplify this expression. I have x plus x. Well, x plus x is 2x, and I'm left with the constant 6. So yes, this is equivalent, right? They have the same value. So yes, this is. B is also. Letter C, let's simplify this expression. I have 2 times a sum, right? And the number 2 next to a set of parentheses, which signifies multiplication. So let's use the rainbow to simplify. 2 times x is 2x. I'm adding. 2 times 3 is 6. Okay, so when I simplify this expression, I get 2x plus 6, which is what I started with. So C is also equivalent. It has the same value. Letter D, 3 times x plus 2 minus x. Let's simplify by using the rainbow, the distributive property. 3 times x is 3x. I'm adding. 3 times 2 is 6. I need to subtract x, right? I'm going to bring that down into my expression. I don't distribute to the x because it's outside the parentheses. Combine like terms. 3x minus x. Those are like terms. 3x minus x is 2x, and I'm left with plus 6, which again is what I started with. That is equivalent. So D also works. Right now I have A, B, C, and D are all equivalent. Let's check option E. Again, I have to use the distributive property here because I'm multiplying 3 times x plus 2. 3 times x is 3x. I'm adding. 3 times 2 is 6. I still need to subtract x and subtract 1, so I bring those down. Subtract x, subtract 1. Combine like terms. 3x minus x is 2x. And then I have constants, 6 and minus 1. Well, 6 minus 1 is positive 5. Okay, so my final expression here for option E is 2x plus 5, and 2x plus 5 is not the same as 2x plus 6, so no, E is not equivalent.